As the car industry evolved, more and more electronic control units were introduced to the car architecture. With the cars more and more complex, each OEM had to develop a way to communicate with the car. So each manufacturer developed their own protocol and tools to be used, meaning that each manufacturer had their own unique way to communicate and to diagnostic the car. The Unified Diagnostic Service originated from the need of a standardized diagnostic protocol across multiple vehicles. UDS is implemented over the communication layer, either CAN, LIN, or Ethernet. As purpose of the UDS, we can highlight: enable a tester to communicate with the electronic control units in the car, read and clear Diagnostic Trouble Codes, the DTCs, monitor data in real time, program, calibrate or reprogram a unit, testing ECU functions, provide access to ECU protected functions through security authentication. We can highlight some of the most common UDS service. Service 10, Diagnostic Session Control. So using this service, we can switch the diagnostic session of the ECU, either programming, extended, or default. Service 11 to reset the ECU. Service 14 to clear stored DTCs. And Service 19 to read the DTCs. But not everything is so easy about UDS. We can highlight some of the challenges. The first one is the increasing complexity. UDS requires a careful calibration and configuration of the ECU and to make sure that the tools are compatible. There is also the security aspect. If you are introducing a way to unlock protected functions, you also need to be aware that maybe hackers will use that instrument that you created to access and to perform malicious actions into the ECU. And as everything in the automotive industry is the real-time challenge. Some of the UDS service, they have real-time constraints, and we need to make sure that we are able to react on the expected time. Okay, so with the help of Canoe, I'm going to demonstrate how we can use the diagnostic service. So I'm going to use the diagnostic console, and I'm going to choose, just for this example, BPC02 ECU. Here on the left, we have the different services that are implemented, and that is standardized throughout all different OEMs. For this example, we have the diagnostic console as the interface connecting the diagnostic tool with the ECU. But in a real car, in a real environment, you need to either have access to the CAN bus or you can access the ECUs through the OBD port. But of course, not all ECUs are unprotected and not all services are available if you are using a production car. Just for this example, we are going to activate some of the service and we are going to see which type of behavior you should expect. So let's just send default session start. So I'm sending the communication TX. I'm informing which ECU I am trying to communicate, BPC02, and I'm getting a positive response from the ECU. So now I can change the diagnostic session. I can go now to programming session, and let's say now the ECU is open to receive a new software. And also I can read information about the ECU, so which is the identification name of this ECU. Let's say I don't know which was the ECU I was trying to communicate. I can also read the serial part number of this ECU. I can read the voltage information of this ECU, so now it's 33.65. That's just, of course, example value, but also I can read the odometer value, the timestamp read. So using those services, I can get the real-time data of that ECU, and also I can diagnose the ECU. So is the ECU working correctly? What's the part number of this ECU? So in summary, UDS is a standardized protocol that you can use to communicate with different vehicles from different OEMs. And that's the benefit of the UDS, because if you have an OBD diagnostic tool, you can use the same tool and the same service throughout the different cars from the different OEMs.